Myself Dr. Saurabh Devna. Today's topic is unsymmetrical fault. This is the second lecture of unsymmetrical fault. Here the topic is operator A or operator alpha. Now operator A or operator alpha is a vector which when multiplied with a vector, the vector rotates 120 degree in anti-clockwise direction. Here it is written, this is the operator A or operator alpha which when multiplied to a vector, the vector rotates 120 degree in anti-clockwise direction. So it is used for analysis of unsymmetrical fault. Now there is the picture, you can see. This is a three-phase system. There is a phase A, phase B, and phase C. When operator alpha is multiplied with I current, here I current is flowing in phase A, it is rotated in anti-clockwise direction by an angle 120 degree. So if I current is flowing to the phase A, so alpha I is equal to, we are going to phase B. When again alpha is multiplied with alpha I, then we are going to phase C. And finally when alpha Qi is multiplied, then we are again go to the phase A. That's why we have written alpha I is equal to I angle 120 degree. You know that angle theta is represented by cos theta plus j sin theta. That's why it is written like this manner. This is the I cos 120 degree plus j sin 120 degree. Now we have calculated and finally get the value of alpha is minus 0.5 plus j 0.866. Similarly, I have already demonstrated that alpha square I is equal to I angle 240 degree. Why 240 degree? 120 plus 120 is equal to 240 degree. That's why alpha square I is equal to I angle 240 degree. Again we are solve it by the formula and finally get the value of alpha square. Alpha square, the value of alpha square is 0.5 minus j 0.866. Now come to the point, that is the alpha Qi. Alpha Qi is I angle 360 degree, and it is after calculation I cos 360 degree plus j sin 360 degree, and finally get the value of alpha Q1. That's why the value of alpha is minus 0.5 plus j 0.866. Alpha square is only the changes of sign here, that is the minus 0.5 minus j 0.866, and finally the value of alpha cube is 1. That's why when we are summating alpha plus alpha square plus alpha cube, putting this you will get the value of is 0. This is the property of alpha. That is the 1 plus alpha square is 0. Now we are making the value of the alpha plus alpha square. Put the value of alpha and alpha square, and finally we have get the value of alpha plus alpha square is 1 minus 1. Similarly, if you have put the alpha minus alpha square, what is the value? Put the value of alpha and alpha square, and finally you have get the value of alpha minus alpha square is j root 3. Now there is the simple solution. Here is the problem where you have there is the left hand side of the problem and this is the right hand side. You have proved that LHS is equal to RHS. Now LHS side, 1 minus a square. We have simplified it a plus b into a minus b, and putting the value of and in the denominator you have common the alpha, and finally solve this and you have get the value of the LHS is equal to RHS. Okay, now come to the second problem. In second problem, the LHS side is 1 minus alpha divided by 1 plus alpha square. Here, from the properties of alpha, you know that 1 plus alpha square is equal to 0. That's why 1 plus alpha square is equal to minus alpha. So put it minus alpha. And here we have multiplied minus alpha square both numerator and denominator, and calculate it and finally get the value. This is the similar value at RHS. This was the simple topic on alpha operator or A operator. Okay. The next topic will be continued in next class.